All right, so we're going to move into my third video of reviewing basic factoring techniques. And so in this video, I want to talk about what we call special factoring formulas. And so there are a few examples out there where there's not really, a clever way to go about factoring something. Instead, it's all about learning a certain formula that matches to the form of the problem you're working on. And so for this video, we're going to cover three different formulas that might be beneficial for you to learn as we go through this course. Now, one thing you will notice about these formulas is that all of them only have two terms, whether that be the a squared minus b squared we're going to talk about in just a second, or we have a cubed plus or minus b cubed. So let's start with the first one. This is called difference of squares. Anytime you are asked to factor an equation where you've got two terms that are being subtracted from one another and both of them can be written as a squared term, we can factor this into a difference of squares. So if you notice, and we're going to see a few examples in just a minute in the video, if you see two terms that are being subtracted and they're squared, if you can identify what the a and b values are that cause them to be a difference of squares, we can factor them into the following form. It would factor into a minus the b term, and then you would multiply that by a plus the b term. But the important thing is you have to identify what the a and b are in order to put it into its factored form. Now, what happens when we move to a cube term? Now, unlike the first one where only subtraction works with squares, with cubes, you can actually do this with addition or subtraction. Now, the good news is that the formulas are very similar, so let's start with that. You'll notice that in this breakdown of the formula, there is a plus sign that I'm going to use red for, and then I'm going to use purple for the minus. The sign that is on top, which in this case is the plus sign, will go with the sign that is on top in the formula to the right. So if you end up taking two terms that are added together and they're both cube terms, you can actually factor this into a plus b, then multiplied by a squared minus a times b and plus b squared. Now you'll notice at the end in front of the b squared, there's not two different symbols. That's because both of these formulas require you to use a plus sign in that last term of the second parentheses. Now be careful, because if we change it up, or if I change it up into two terms that are being subtracted and they can be written as cube terms, that would be a cubed minus b cubed, which the minus on the bottom would go with the minus on the bottom of your first parentheses, and then your next term would become plus. So it would be a minus b multiplied by a squared plus a times b, and then, like I said, the same as the last one, plus b squared. And so in this video, what I'm going to do now is I'm going to show you two examples of each kind that you can use the special factoring formulas for. So let's begin with the first three that are pretty straightforward, and then I'll show you a couple that may be a little trickier that we'll see later on. So beginning with the first one, you want to factor x squared minus 121. Well, typically when I factor things like this, I look for two things. Number one, what's the power? So you notice that it's a squared, and also that it has a minus symbol. And so when I go back into my mind about the formulas that we're learning, I notice that this can be written as a squared minus b squared. And that's a giveaway because you've got a squared term at the beginning and you've got a minus in between them. Now, the biggest challenge for most students here is to know what formula or what a and b are in this formula. So what I typically do is I'm going to take the original formula and I'm going to try to write it in the form of a squared minus b squared. Now, the first one's always the easiest, at least in this case, because if you're asking yourself what squared gives you x squared, well, then it would just be x. So in this case, replacing a with x, and if you square x, you're still going to have x squared. And then if you ask yourself at the end, What number squared would give you the 121? Well, I know from either using your calculator or some of y'all might know by memory is that 11 squared is 121. And now you notice that our original problem matches the form of difference of squares. Now, difference of squares does factor into a plus b and a minus b. So all you have to do at this point is you'll notice that we have now found our a and b value. We can plug both of those into our factored form. Oops, sorry, y'all. Which will end up giving us, there we go. Sorry, I hit the wrong button and it jumped to the top. We can plug our a and b in, and that would give us x plus 11 and x minus 11. That is the factored form of number 1. For number 2 and number 3, now you see that while we still have 2 terms, we're now moving into our cubic examples because of the x cubed at the beginning. So let's see if we can match this the exact same way. I see a cubed and I see an addition sign. So what I'm going to try to do is to match this into the form a cubed plus b cubed. So you got to ask yourself again, what cubed plus what else cubed would make this equal the original problem? Now, like I said, the first one's always the easiest because in order to get x cubed, you have to cube x. And so that's going to end up being our a value in just a second. And then either using your calculator or thinking about it however it works best for you, we can come to find out that the number 5, if you cube the number 5, 5 times 5 times 5 is 125, which then gives me the b value that we need. Since I've identified my a and my b value, I would then go to my formula, and for a cubed plus b cubed, you're going to factor this into a plus b times a squared minus ab plus b squared. All you got to do now is plug your a and b value in, and that will help you in the factored form. So this would end up being x plus 5, because that's my a and b. And then inside of the second parentheses, you're going to have to do a little bit more work here, because you have to square your a value. Well, since a is x, if you square that, it becomes x squared. Minus, you will multiply your a and b together. So x times 5 would give us 5x. And then plus, if you square your b value, 5 squared is 25. This is your factored sum of cubes formula. Difference of cubes is very similar, so I'll kind of go through the same process here. Once again, you notice that there is a cube term and there's subtraction. So I'm trying to match this into the form a cubed minus b cubed. Well, once again, think about what numbers you have to plug in to make it match the original problem you're trying to work. Once again, x, what cube gives you x cubed? Well, that's going to have to be x cubed. And so once again, for the third time in a row, our a value is x. Then you got to ask yourself, what cubed would give us the 64 in the original problem? And so going through your mathematics here or your arithmetic, you can find out that 4 times 4 times 4 will give you 64. So in this case, our b value ends up being 4. For our subtraction of cubes formula, it is a little different from the one above because the first two signs are different. You're going to have a minus b times a squared plus ab plus b squared. And if I plug my a and b into all of these parts, you should get x minus 4. If you square your a value, you will get a squared again. Plus a times b would give you 4x. And then b squared 4 times 4 gives you 16. And this would be your factored form of the difference of cubes. Now, those are the first 3 that I wanted to work. There are some that follow this form that are a little bit trickier. And so what I'm going to do on the next slide is throw you a couple, or 3 of them actually, that while they follow the same rule, finding your a and b may be a little bit different. So let's look at those next. So I'm going to call these the harder examples because they are not as straightforward as the ones we just did, but they're still going to follow the same formulas. So let's start with number 1. You've got 9 minus 4b squared. Now, once again, what jumps out to me is that there's 2 terms. So usually in my mind means I'm going to use a formula. I see a squared term and I see subtraction. So I know from my formulas that we have a formula for squared terms being subtracted from one another. Now, what you've got to be able to do is to write your original problem as something squared minus something else squared. And so in this problem, since our first term is 9, if you're trying to think about what squared gives you 9, it ends up being 3. And so that's going to end up being our A value in just a minute. And then if you ask yourself what squared gives you 4b squared, not only is it the b that kind of jumps out to everybody, you have to also think about it being a 2 in front of it, because 2 times 2 gives you the 4 that you need, and b times b gives you the b squared. So in this case, the b in our factored formula will be 2b. And so now that I have all that written down, I know that my difference of squares factors into a plus b times a minus b, which will end up giving me 3 plus 2b and 3 minus 2b. That is the factored form of number 1, all right, in the harder examples. We can do the exact same thing with the cube. So let's go through that 2 more times, and that'll kind of wrap up the video here for special factoring formulas. So I've got 8w cubed plus 27. Well, I see a cubed and I see a plus symbol. So that tells me I'm going to try to fit this into the form a cubed plus b cubed. So if I think about, oops, not squared, we got to rewrite this as something cubed plus something else cubed. And that comes from the original problem. So for the 8w cubed, the easy part is the w, because you got to leave that letter the same. But as far as the number goes, you have to ask yourself what multiplied by itself 3 times will give you 8, and that will end up being 2, because 2 times 2 times 2 gives us the 8 that we need. For the 27, you got to think about what number multiplied by itself 3 times gives you 27, and that should be 3, because 3 times 3 times 3 is the 27 that you desire. And just like the last 4, that gives me my A and B value that I need. And if I go to my sum of cubes formula, because we're doing addition, that would be A plus B, A squared minus AB plus B squared. And then I'm going to plug my numbers in. So this will be 2W plus 3. If I square the A value, 2 times 2 is 4, and then W squared, minus, I'm going to multiply the A and B value together. So 2W times 3 should give you 6W, and then plus, I'm going to do B squared. So 3 squared should give us 9. And this is your factored sum of cubes formula following the same structure. Hopefully through 5 of them, you're starting to see the pattern of how you find your A's and your B's and your formulas. But let's just do one more to wrap up this video. And we're going to do 64 minus 125z cubed. So once again, I see the cube term. I see the subtraction. So I'm going to try to write this in the form a cubed minus b cubed. And so if I'm going to take the original problem, and I've got to figure out what my A and B value are. So let's see. What cubed will end up giving me 64? We saw this in a previous example. It would be 4. 4 times 4 times 4 gives you 64. And then what cubed gives you 125z cubed? Well, the variable can't change, so that's going to be z. And then in this case, if you do 5 5 times 5 times 5 gives you the 125 that you need. You've got your A, you've got your B, and so for the difference of cubes formula, that is A minus B times A squared plus AB plus B squared. And so plugging my A and B in, you should get 4 minus 5Z. If I square A, that gives me 16 because that's 4 times 4, plus A times B should give you 20Z. And then plus, if you square your B value, 5 times 5 is 25. Z times Z is Z squared. And this gives you the factored form of your more complicated difference of cubes formula. And so in this video, we went over 3 special factoring formulas that are only used when you've got 2 terms that are either squared and subtracted, or you could do both of them are cube terms, and we've seen that addition and subtraction will work. And so that wraps up the 3rd kind of factoring you have to be comfortable doing in this course.